There's something weird happening up in the atmosphere of the planet Uranus. Every once in a while, it produces these bright, high-altitude clouds that are only visible in infrared light. They seem to move around really fast, and then they disappear just as quickly, leaving scientists scratching their heads over what the heck is going on. But thanks to a new study, we may finally have some answers. It all started back in 2014, when the Hubble Space Telescope was observing Uranus in infrared light. Suddenly, the telescope picked up this strange bright cloud in Uranus's northern hemisphere. At first, astronomers thought it might be some sort of artifact from an instrument on board the telescope. But similar features had been spotted by other telescopes on Earth and in space. And so this particular mysterious bright cloud turned out to be a real thing. Since then, we've spotted about a dozen or so of these things across the planet's northern and southern hemispheres. They appear, linger for a few weeks, and then vanish without a trace. So astronomers set out to find out what's behind these sudden cloud formations. The new study was led by researcher Christina Arvua at the University of Berlin, and her team took a two-pronged approach to studying these clouds. First, the team developed a model that simulates the conditions in Uranus's atmosphere. Then they looked at the chemical processes occurring in that simulated atmosphere to try and figure out what could be responsible for creating these clouds. But before we get into what they found, let's talk about Uranus itself, because this sideways planet is quite a bit different from Earth. Uranus is an ice giant, meaning that most of its atmosphere is made up of lightweight elements like hydrogen and helium. There's also a good amount of methane in there, which gives the planet its distinctive pale blue color. And like Earth, Uranus has clouds, but they exist much higher above the planet's surface due to those lightweight elements. Earth's atmosphere is divided into layers based on temperature. The lowest layer is the troposphere, where most of the weather happens. And the boundary between the troposphere and the next layer up, the stratosphere, is called the tropopause. And this is where clouds typically form on Earth. Because as the air in the troposphere rises and expands, it cools to the point where water vapor condenses into liquid droplets, or ice crystals forming clouds. But on Uranus, the tropopause exists more than 1,000 kilometers above the planet's surface, and it's way too frigid for clouds to form there. Uranus's atmosphere is so cold that if liquid water clouds did form, they would instantly freeze into ice crystals. That's why the clouds we see on Uranus are actually higher up in the stratosphere, which makes them even more puzzling. Since stratospheric clouds don't form in the same way as tropospheric clouds, they're not very common in planetary atmospheres. To make matters even stranger, unlike most stratospheric clouds which are opaque, these clouds on Uranus are weirdly translucent. This is probably due to the extreme cold and low pressure conditions high up in Uranus's atmosphere. These conditions cause the clouds to have a crystalline structure that lets light pass through. And that's how these clouds can be spotted in infrared images. These images show light that's been filtered to let only certain wavelengths pass through. The reason for doing this is that Earth's atmosphere blocks a lot of the light we receive from space. By using filters, astronomers can select specific wavelengths that aren't absorbed by Earth's atmosphere, which allows them to see things that would otherwise be invisible to us. For example, the James Webb Space Telescope can see in infrared light, which allows it to look through dust clouds and see things like star formation in places like the Eagle Nebula. So while these clouds on Uranus are opaque in visible light, they become translucent in the infrared, which is how we're able to see them. Now, seeing these clouds is one thing, but figuring out what they're made of and why they form so suddenly is another. And this is where the second part of the study comes in. To figure out what could be causing these clouds, the research team created a computer simulation of Uranus's atmosphere, and then tweaked the model to try and match the conditions under which the clouds form. One of the key features of their simulation was a dynamic tropopause, meaning the boundary between the troposphere and the stratosphere moves up and down in response to changing atmospheric conditions. On Earth, this kind of up and down motion is driven by changes in temperature and pressure that occur as the planet rotates, and the sun shines on different parts of the surface. But on Uranus, which rotates almost perfectly on its side, there isn't much variation in temperature or pressure. So the researchers decided to spice things up by adding in some extra heat. In their simulation, this extra heat caused convection currents in the atmosphere, which led to the formation of clouds at the tropopause. When they added just the right amount of heat, The model reproduced the observed characteristics of the clouds, including their crystalline structure. This suggests that these clouds form in a similar way to ordinary clouds on Earth, but with some key differences. For one thing, instead of water, these clouds are made of methane that condenses into ice crystals when it reaches the frosty tropopause. And instead of being opaque, these ice crystals form a lattice structure that scatters infrared light, giving the clouds their bright appearance. Now, this might make you wonder why the clouds only form every once in a while, if the conditions are always the same. And that's because the researchers think the process that forms these clouds is triggered by some kind of shock. In their simulation, they were able to reproduce the sudden formation of clouds by adding a shock wave to the model atmosphere. This shock wave could be caused by something like a large meteor hitting the planet, although no meteors have been observed to coincide with the appearance of the clouds. It could also be caused by atmospheric gravity waves, which are oscillations in the atmosphere that can be generated by all sorts of phenomena, including changes in temperature and pressure, wind shear, and even the passage of storms. Of course, this is just a model, and the real atmosphere of Uranus is a lot more complicated than what can be reproduced in a simulation. But the researchers think their model provides a plausible explanation for the origin of these clouds. And in future work, they hope to collect data on the shockwaves in Uranus's atmosphere that could be causing them. Ultimately, understanding the conditions that form these strange clouds will help scientists better understand the complex atmosphere of this unusual planet. And who knows, maybe we'll learn that there are even stranger things going on up there in the frigid skies of Uranus. Speaking of strange things in space, there's something strange happening to my hairline. If you enjoyed this video, you can watch another one right here. And if you want to support the channel, you can head on over to our support page. Thanks for watching.